In this lecture, let us discuss about FastText model, which is an open source library developed by Facebook's AI Research Lab, which is useful for text classification and other word representation tasks. Most traditional word embeddings like word to vec or glove represent each word as a single vector, whereas FastText improves on this by breaking down words into smaller subword units, which are also called as n-grams, making it more flexible and powerful. And it is good at handling out of vocabulary words. Say if a word has never been seen in the training corpus, traditional models like word to vec can't represent it at all. Whereas FastText can generate embeddings for out of vocabulary words by looking at the subword units, which are nothing but n-grams that make up the word. What are character n-grams? This is a sequence of n consecutive characters for a word. Say, for example, if you take the word apple, unigrams are nothing but the individual characters or words from the original sequence. So in case of character unigrams, each character of the word is treated as an individual token. So for this apple, here each character in the word that is treated as an individual token. So here you can see that P appears twice because it's a repetition in the word, and each occurrence of P is treated as a separate unigram. And second one is bigrams, which are the sequences of two consecutive characters. So for each pair of adjacent characters in the word, we create a bigram. For the word apple, bigram would be AP, so two characters PP, PL, and LE. So here AP is the first bigram formed by the first two characters. This is the second bigram formed by the next two characters, and so on. So until we reach the last pair of characters, we need to repeat this process. And third one is trigrams, so which are the sequence of three consecutive characters. In case of apple, the trigram would be this APP is the first trigram formed by the first three characters, and this is the second trigram formed by the next three characters, and so on until we reach the last set of three characters. So why character engrams helps in out of vocabulary words? So FastText, as mentioned earlier, it represents each word as a set of character engram. So this allows FastText to generate embeddings even for words that were never seen during the training, which is nothing but out of vocabulary word. And if you consider this word playing, let us break that word into character engrams like this. So you can see the engrams here, character engrams, one unigrams. So here every character is treated as a token. So we just follow the same thing which we followed just now. So we considered the example for apple, same will be considered for this playing as well. So FastText uses these engrams to represent words in a way that can better capture morphological structures. So using this, it can capture morphological structures like play, playing, played, etc. Let us see the implementation part. So here first we need to install the FastText library, and after that, once this FastText is installed, you can import FastText and other useful libraries for handling data and visualizing the output. And step 3 is you need to create and save the sample corpus. So this FastText works with text data. You can create a simple text corpora directly within the Colab. So this will serve as the input for training your model. So here you can see the corpora. And this actually creates small text file called data.txt, which we will use to train the FastText model. And then after that, you need to train a FastText model, which can be done using either skipgram or cbub. So this is an unsupervised FastText model. Train unsupervised of data.text comma model equal to skipgram. So this example trains a skipgram model. So skipgram means it tries to predict the context words from the target word. If you change this to cbub, then you can even train model using cbub also. And after that, we need to save the model. Then get the word embeddings or word vectors. So once a model is trained, then you can extract the word vectors or embeddings for any word in the vocabulary. Okay. So here we are getting the word vector for word sentence. So this second statement, this print, it prints the word vector that is a numerical representation for the word sentence. Here we need to find the word similar to a word sentence. So FastText can also be used to find words that are most similar to a given word based on cosine similarity. And after that, we need to train a FastText model for text classification. That is, we are doing supervised learning here. So FastText can also be used for supervised text classification tasks. We also know that, right? So you'll need to prepare label data for training in this case. So let us see that. So here you can see this. First, we need to create a label dataset for classification. For that, we are creating a simple label dataset for sentiment analysis. So here you can see each line has a label, either label positive or label negative, and the text of that particular document. Then we need to train a text classification model. So for that, we are using FastText on the label text classification data. So here train unsupervised of train.text. It represents that training is done on supervised model using a label dataset. Then you need to save the classification model at this point. And then we need to make predictions using the train model, right? So for making the predictions, we are writing this. So you can now use the train model to predict labels for new text. This will predict whether the given text has a positive or negative sentiment based on the training data. So you can see this classifier.predict of text. So which will predict whether the given text has a positive or negative sentiment based on the training data. And finally, evaluate the classification model. So for that, first you need to create a test data set. So here you can see we are creating a test data set with the labels and the corresponding text in that document. Then we need to evaluate the performance of your classification model using this test data set. So here we are using metrics like precision, recall. So what is precision? The proportion of the true positives among all positive predictions. And recall is proportion of true positives among all actual positive instances. So after execution, you will get the output like this.